So, once again, welcome, dear friends. Let us solve this problem. The problem statement is here. Three forces are acting on a vertical plate. The plate name is OABC of size 4 meter and 5 meter as shown in figure. Find the resultant of the force. So what we have to find out here, we have to find out the resultant of the force. Okay, so this plate is vertical plate. You can see this plate here where my cursor is there. This is vertical plate, and the x, this is the x-axis, y and z here. Okay, and what are those three forces? So this one at A 60 kilonewton, at B 40 kilonewton, and at C 50 kilonewton. And O is here origin. O is origin. Okay, and what about the size? And what is the name of beam? So this is the OA. Sorry, beam, not a plate, vertical plate. OABC. So this OA, from O to A, then B, then C here. And the dimensions are given, AB of 5 meter and BC of 4 meter. Okay, and what we have to find out? We have to find out the resultant. Our resultant is what? Resultant, this we have to find out. Okay, so what about the directions? The forces here, you can see the force is here 60 kilonewton. It is acting at A and it is parallel to X. What about 40 kilonewton? It is also parallel to X, and this 50 kilonewton is also parallel to X. So firstly we have to find out the here resultant we have to find out. So how to find out the resultant? So solution, first step is our to find out resultant. So you can see the 60 kilonewton, 60 plus this 40, then minus 50 kilonewton is equal to 50 kilonewton. And next step is we have to take we have to use Verignon's theorem to get the position of the resultant R. Okay. So what about if we get summation of about my? So as per this will be R multiplied by Z. Let us okay. Okay, so our purpose is to know about, because the vertical plane y, the vertical plane lies in YZ plane. Okay, so that's why we have to get, that's why we have to get either means by both moment about my and moment about mz. So this equal to r z and this equal to r x. So this mz is equal to uh, this is r y. Okay, so this y coordinate we have to know, z coordinate we have to know of the resultant. Okay, so how to get this? So that's why two times we have to apply the Verignon's theorem. So first step we have done. What is the first step? The first step, getting the resultant, and this we are doing through the scalar approach, scalar method, because it is very easy as compared to the vector approach. So second step, that is the summation of moment about y is equal to this resultant, and it is multiplied by z. And this cross is not the this is just a multiplication, not the cross product. It is the or also you can write r dot z. Okay, now what we have to do for this, so summation of a moment about y, and where is your y? So if you extend this one, so it is y minus. Okay, and the summation of moment about y. So what are the forces? This 60 kilonewton. This 60 kilonewton is passing through the point A, and it is on y direction. Okay, so there will be no perpendicular distance will be getting, so that's why here the 60 into 0 we have to do. And suppose we are taking the moment about y we are taking, and this is the clockwise we are supposed taking minus the clockwise minus, so that's why it is minus. And what about the other force? That is the 40 kilonewton. So 40 kilonewton, and this 50 kilonewton. Okay, so 40 kilonewton, that will be it is the anti-clockwise. That's why plus 440 multiplied by 5. Y multiplied by 5, so you can see this 40 kilonewton, and the perpendicular distance is this one, this 5 meter. Okay, that's why we are taking multiplying by 5. And similarly for this 50 kilonewton. Okay, here it is acting, so this distance, the parallel from here to here, it is 5. That's why for the both forces 40 and this 50, so 40 with the positive and 50, so 50 is what here, so it is clockwise. That's why 50 into 5, and it is equal to r multiplied by z, and r we know that is 50. Okay, so by solving this, what we get z is equal to minus 1 meter. Okay, this is our z coordinate of the resultant. This we have done. Okay, next what we have to get? So we have to get the y. What about y? So we have to get the y. So for that, this one we have to apply, and that is the third step. Summation of m z is equal to r multiplied by y. Okay, and now see, so moment about z. So moment about z, for that what we have to do? So this 50 kilonewton, force which is acting at C but lies on z direction. Okay, and the moment is about its own axis. That's why there will be no perpendicular distance. Okay, so starting from the force acting at A, so same here, 60 and multiplied by, so now from Z we have to take this perpendicular distance. So from Z axis it is 4 meter. Similarly, this 40 kilonewton, the same, this 40, and it will try to rotate anti-clockwise. Okay, as this we are taking negative. Okay, the clockwise we are taking negative. So 40 multiplied by the base distance. So same here, it is the moment about Z we are taking. So it is multiplied by the like 60 kilonewton, and similarly 40 kilonewton multiplied by 4. Okay, and what about this one, plus 50 and multiplied by 0? Why? This is, it is lies, this force is lying on the Z axis itself, that's why. Okay, and is equal to what we have to take, that is R and Y. R we know 50, that is 50 kilonewton. Okay, so by solving this, what we get? For we are taking common, so it is 60 plus 40 is equal to 50 y, and then 4 minus 20 is equal to 50 y, and then y is equal to minus 4 into 20 divided by 50, this minus 8 divided by 5, and that is equal to minus 1.6, and it is in meter. So what we got, our answer is resultant lies at this one, resultant, that is equal to 50 kilonewton at 8. Suppose that is P, and x is equal to what we got, so x is equal to 0, and y is equal to 1.6 with minus sign, and z is equal to minus 1. So let us the R is with positive kilonewton, so R acts somewhere, this is all this with meter and meter. Okay, so from y, if you extend this, okay, and this is the minus y axis, so it is somewhere like this it is like this distance from here, and what about z axis? So z axis, it is in minus. Okay, this is minus z axis, okay, and that resultant is lying in between the minus, positive, and minus z direction. So somewhere like from here to here it is minus 1. So here you can say the P, the resultant this is the resultant, okay, lies in the minus yz plane. Okay, so in this way we have done this. So what we did, uh, so our purpose was to get the resultant of the force, and this is the vertical plate lying in y z directions. So firstly, what was our purpose? To get the resultant. This is 50 kilonewton, and then next was to get the y and the z coordinates. The next purpose was to get y and the z coordinates, and that can be found out by applying Verigna's theorem for twice to get the z and y coordinates. So in this way, we got z coordinate, that is minus 1 meter, and also by applying the moment about z, and that is equal to r y, then we get y is equal to, this is y is equal to minus 1.5 meters. So our r resultant acts at p, that is 0 minus 1.6 minus 1 meter. So this is the final answer. Okay, this we solved by using scalar method. Okay, so we opted scalar method. Okay, so in this way we have done. Thank you.